First, let's try to understand what is geometric progression. So there is a series that's given. We need to understand if this series can be called a geometric progression or does it follow the geometric progression. Let's look at an example series which is a geometric progression: 1, 2, 4, 8, 16, 32, etc. If you remember, in arithmetic progression, what did we do? We found the difference between the two consecutive terms. It is increased by +1, +2 in this case, 4, then I see 8 and 16. You see, the values are not same. So that means this series is not arithmetic progression for sure. So how can I check for a geometric progression? You need to do pretty much the same thing, but not the difference, but rather division of it. So nth term by n minus 1, the previous term, 2 by 1 should be equal to some fixed value. What is that? 2. What about 4 by 2? Is also 2. 8 by 4 is also 2. 16 by 8 is also 2. And 32 by 16 is also 2. You see? So this means I am finding the nth term by n minus 1th term, a fixed value, that's called common ratio. How we called the difference to be common difference in arithmetic progression. Then this series is basically a geometric progression. If I have series like this, two by 1, 2, 4 by 2 is 2, 16 by 4 is 4, 24 by 16 is 3 by 2. You see, 2, 2, 4, 3 by 2, the ratio is not same. The ratio of nth term and the n minus 1th term. Any two consecutive terms I take, the nth term and the previous term, the division, the ratio of them should be a fixed number. They are not same. That's why this is not a geometric progression. This is a geometric progression. So similar to the arithmetic progression, we'll have first term of the series denoted by A. Instead of common difference, we have common ratio denoted by R. The ratio, that's why we have R. And nth term of whatever, so n would be the number of terms. That will be a parameter as usual. So let's look at the formulas for the nth term and the sum of the first numbers. So nth term of a geometric progression is denoted by A into R power n minus 1. If you see, remember the previous geometric progression we had, first term, second, third, fourth, fifth and sixth. What is the common ratio we had? 2. 2 by 1, 4 by 2 is 2 and the first term is 1. If I am trying to find the sixth term, T6, it will be denoted by A into R power 6 minus 1. That's 1 into 2 power 5. 2 power 5 is 32. So that's why the sixth term is 32. If I ask you to find the 100th term, it will be 1 into 2 power 100 minus 1. That's basically 2 power 99. So I don't know what's the value of 2 power 99. But that's good enough for us to understand how we can calculate the nth term of a geometric progression or series. Similar to the arithmetic progression, we also have a formula to find out the sum of first n numbers of a geometric progression. So if I am trying to find the first 5 numbers, 1 plus 2 is 3, 4 plus 4 7, plus 8 15, plus 16 31 is the sum of first 5 terms for the given series. So if I use this formula, it will be calculated as 1 into 2 power 5 minus 1 by 2 minus 1. So 2 power 5 is 32 minus 1 is 31 into 1 is 31 by 2 minus 1 is 1. So that's why the answer is 31, which is what we got. We can use this to find the values like sum of first 10 terms, 15 terms of a geometric progression. In some books, you'll see formulas being written, 2 formulas for the same first 10 terms. They'll say if the common ratio is greater than 1, we'll use A into R power n minus 1 by R minus 1. If the common ratio is less than 1, we use A into 1 minus R power n by 1 minus R. So there is not much of a difference between these two. Don't worry about remembering 2 formulas. So it's because R is less than 1, 1 would be greater than r power n, so that's why they are writing it as 1 minus r power n by 1 minus r, which is basically writing minus sign here and minus sign here, you'll get the same. So don't worry about this formula, stick to this, you'll not get any wrong answer. Right, you might also see a decreasing geometric progression, like same example, 1, 1 by 2, 1 by 4, 1 by 8, etc. What is the common ratio here? 1 by 2. 1 by 2 by 1 is 1 by 2. 1 by 4 by 1 by 2 is 1 by 2. 1 by 8 by 1 by 4 is 1 by 2. So this is decreasing. The first term is larger than the second term is larger than the third term. Unlike here, it's an increasing geometric progression. Right? As I said, the common difference could be positive or negative. For an increasing arithmetic progression, the common difference would be positive. For decreasing, it would be negative. Similarly, for a geometric progression and increasing geometric progression, we'll have a common ratio r greater than 1, and a negative will have a common ratio less than 1. We can also have a negative common ratios. It's not that it is not an impossible thing. Finally, we can also have a series where the geometric progression will keep continuing towards infinity terms. Let's look at the same series that we have talked. 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on. If I say infinite terms, so it will go in the same pattern. If I ask you, can you give me the answer? What is the sum of this series till infinite terms? This is an approximation. You can use this formula to answer that. So what you need to do is, first term is a, 1 by 1 minus half is the common ratio. So this will turn out to be 1 by 1 by 2, that's 2 is the answer for this series. So that's something you can do for a series like this, but I cannot do what is the sum to infinite terms of 1, 2, 4, 8, 16, 32, 64 and so on up to infinite. You see the series is increasing. 1, 2, 4, 8, 16, 32, 64, the numbers would be larger and larger and larger. The answer would also be infinite. Sum to infinite terms for that series is basically infinite, because that will be a very big number. But here I see the value is going smaller and smaller and smaller. After a point they will not add much value. That's why we can use this approximation to answer the question. So this is a specific formula that you will see in a geometric progression. You won't see in sum of infinite terms for arithmetic progression. So just keep in mind this formula with specific to geometric progression. It's an approximate formula, but that's enough for you to solve a problem if it is asking you to find sum of infinite terms. But keep in mind this formula would work only if r is less than 1. Other than that, if r is greater than 1, the answer should be infinity only for the sum of infinite terms. So let's solve some problems. Again, if you are watching this video, do pause the video and attempt all these questions on your own, one by one. Then continue after you have attempted it and check the way we are solving, so that you'll get a clarity on if you've got the answer, is it the best way, or if you haven't, what's the reason that you could not get the problem. So a series S is defined as following: Sn into Sn is equals to 2 into Sn minus 1. If you remember, we had something similar in arithmetic progression example problems. Over there we said try to get Sn minus 1 is equals to what? If it's a fixed number like a constant 5, 10, 20, I understand that the series is following arithmetic progression. Something similar that you can do and check if a series is following a geometric progression or not by getting it to this thing. Sn by Sn minus 1 is equals to a fixed number. In this case, Sn is 2 into Sn minus 1. If I send Sn minus 1 here, it will turn out to be 2. That's a fixed number. What do I mean by fixed number? If I have Sn by Sn minus 1 as 2n, then this is not a fixed number. As n changes, this ratio will also change. If n is 2, S2 by S1 is 2 into 2 is 4. S3 by S2, when n is 3, is 2 into 3 is 6. You see the common ratio is not fixed. It is changing. It's not a common thing anywhere. But if it is Sn by Sn minus 1 is 2, irrespective of n being 2, 3, 4, everything, always the ratio will be 2. So that means I can understand that this series is following a geometric progression. Based on this, I understood the common ratio is 2. They said fifth term is 32. That is basically a into 2 power 5 minus 1. So 32 is equals to a into 2 power 4 is 16. So the first term is 2. Now they are asking 100th term. So 100th term is written as a into r power 100 minus 1. That's 2 into 2 power 99. Though that's basically 2 power 100 is the answer for this.